On February 24th, 2022, at approximately 4 in the morning, something unprecedented happened in the history of modern warfare. Hours before Russian tanks crossed the Ukrainian border, Moscow launched a devastating cyberattack that knocked out Viasat, Ukraine's primary military communications network. In the opening moments of the largest land war in Europe since 1945, Ukraine's ability to coordinate its defense went dark. What happened next would reshape how the world thinks about space. Within 12 hours of a desperate tweet from Ukraine's Minister of Digital Transformation, Mikhailo Fedorov, Elon Musk's Starlink was online over Ukraine. Within 48 hours, terminals were arriving by the truckload. By the time Russian forces expected Ukraine's communications to collapse, Ukrainian commanders were coordinating counterattacks through a network of thousands of satellites orbiting 550 kilometers overhead. Drones were feeding targeting data to artillery units in real time. The siege of Mariupol was being documented to the world. The Ukrainian government remained connected. One system, one company, one man's decision, made in the time it takes to post on social media. Today, Starlink dominates space-based internet like nothing before it. More than 9,400 satellites in orbit. Over 9 million subscribers in 155 countries. SpaceX launches 24 satellites at a time, sometimes multiple times per week. The constellation accounts for 65% of all active satellites in orbit. Starlink isn't just a technology, it's become infrastructure. The kind of infrastructure that can tip the balance of a war. And for years, the assumption in Washington was simple. No one else could build this. The technical complexity, the launch cadence, the manufacturing scale. Surely China was a decade away, at minimum. That assumption was about to be proven spectacularly wrong. To understand why China's response shocked Western analysts, you have to understand what Starlink actually requires. This isn't just about building satellites. SpaceX manufactures up to 45 satellites per week. They launch more than 100 missions a year. They recover and reuse their rockets. They've vertically integrated the entire process. Design, manufacturing, launch, ground stations, user terminals, under one company. No one else on Earth had demonstrated anything close to this capability. China's space program, while impressive, was built on a fundamentally different model. Large, expensive satellites, state-run programs, careful, methodical timelines. Their commercial space sector was nascent at best. Their launch cadence, while growing, was nowhere near SpaceX's relentless pace. Consensus view was comfortable. China might build a constellation eventually, but it would take years, perhaps a decade, to scale up manufacturing, develop the launch infrastructure, and deploy anything remotely comparable to Starlink. Besides, this was commercial internet service. Even if China built something, would it matter? Starlink had first-mover advantage, global brand recognition, and a proven track record in the most demanding environment imaginable, active warfare. But Western analysts were making a critical error. They were evaluating China's capability through a commercial lens. Beijing wasn't watching Ukraine and seeing a business opportunity. They were watching Ukraine and seeing an existential threat. Chinese military researchers at the National University of Defense Technology published papers analyzing Starlink's battlefield performance with alarming urgency. They noted how it enabled real-time drone coordination, how it survived Russian jamming through rapid software updates, how it provided Ukraine with command and control capability that traditional systems couldn't match. One phrase appeared again and again in their assessments: huge potential for military applications. China wasn't building a Starlink competitor. They were building a countermeasure. In April 2021, almost a full year before the Ukraine invasion, the Chinese government quietly established a new state-owned enterprise. It was called China Satellite Network Group, or China SatNet. Its mission: build a national megaconstellation, codename Guowang National Network. The target: 12,992 satellites. Then came Qianfan, 1,000 sails, a Shanghai-backed commercial constellation, another 15,000 satellites. Combined, China announced plans to deploy nearly 28,000 satellites into low Earth orbit. For context, that's more than double the total number of satellites currently in orbit from all countries combined. The first operational Guowang satellites launched on December 16, 2024. Qianfan's first batch launched in August 2024. As of late 2025, China has over 200 constellation satellites in orbit and is accelerating. But here's what truly alarmed Western observers. According to Taiwanese intelligence reports from February 2024, before the first operational satellites even launched, Chinese Coast Guard vessels were detected conducting tests in the Taiwan Strait. The analysis suggested they were testing Guowang's integration with something unexpected, the DF-21D and DF-26B ballistic missiles. The DF-21D is known as the carrier killer. The DF-26B can reach Guam. This wasn't a commercial internet project with military applications. This was a military system with a commercial cover story. Chinese state media has been explicit. Guowang will carry broadband communication payloads. Yes, but also laser communication, synthetic aperture radar, and optical remote sensing. The satellites are designed to support targeting, navigation, and what the Chinese call information security, a polite term for signals intelligence. Western media kept comparing Guowang to Starlink. Comparison was dangerously incomplete. The obvious question, did they copy it? Architecturally, the similarities are striking. Both constellations use flat-panel satellites in low Earth orbit. Both operate in similar frequency bands. Both utilize inter-satellite laser links to reduce ground station dependency. Both are designed for rapid deployment using heavy-lift rockets. Even the form factor is similar. Qianfan satellites weigh approximately 300 kilograms, comparable to Starlink's V1 generation. They orbit at roughly 800 kilometers, somewhat higher than Starlink's 550, but within the same operational band. The constellation architecture, shells of satellites at multiple orbital planes and altitudes, mirrors Starlink's approach almost exactly. But here's what makes the copy narrative complicated. China's capabilities aren't built on nothing. They've demonstrated indigenous satellite manufacturing for decades. They developed Beidou, their GPS alternative, entirely domestically. Their quantum communication satellites and space station represent genuine technological achievement. More importantly, there's a practical argument. When solving the same engineering problem, you often arrive at similar solutions. Low Earth orbit megaconstellations have inherent constraints. You need a certain number of satellites at certain altitudes to achieve global coverage. Flat panel designs optimize for mass production and launch density. Inter-satellite links reduce ground infrastructure requirements. Maybe China didn't copy Starlink. Maybe they're just solving the same physics problem the same way. Consider the timeline. SpaceX spent nearly a decade developing Starlink before launching its first operational satellites in 2019. China went from announcement to deployment in roughly 3 years. According to a 2025 RAND Corporation analysis, Chinese military researchers view Starlink explicitly as a template. Their papers reference SpaceX's architecture directly. PLA analysts have proposed detailed counter-Starlink strategies that assume intimate knowledge of how the system works. Leaked Chinese presentation reportedly detailed cataloging Starlink deployments by launch batch and erecting a Chinese space fence radar network to track every satellite. They're not just building a competitor, they're building a response to a system they've studied obsessively. Whether that constitutes copying depends on where you draw the line between inspiration, reverse engineering, and independent innovation. Here's what matters more than the copying question. By the early 2030s, if both Guowang and Qianfan reach their deployment targets, China will have more satellites in low Earth orbit than any other nation, including the United States. Under International Telecommunication Union regulations, China's SatNet must deploy half of Guowang's 13,000 satellites by 2032. The race isn't theoretical, it's mandated. And those satellites won't just be providing internet to rural villages. They'll be feeding targeting data to missile systems. They'll be providing secure communications for Chinese naval vessels in the South China Sea. They'll be creating redundant command and control infrastructure that can survive the kind of electronic warfare Russia tried and failed to use against Ukraine. The same capability that let Ukraine resist invasion may one day let China project power across the Pacific. Starlink proved that space-based communications aren't a luxury, they're a strategic necessity. That's a lesson Beijing learned, and they learned it watching American technology decide the outcome of a European war. There's an irony here. SpaceX built Starlink as a commercial service, but by demonstrating its military utility so dramatically, they may have accelerated the very competition they now face. Whether China's megaconstellations are copies or competitors might be the wrong question. The outcome is identical either way. The comfortable monopoly is over. The assumption that America would control space-based communications indefinitely has been proven dangerously naive. New space race isn't about who gets to Mars. It's about who controls the infrastructure of modern warfare. And it's happening right now, 500 kilometers above your head. In the end, maybe the only question that matters is this: does it change anything if they copied it? If the satellites work just as well?